In this video, we will be learning about basics of recursion from beginner's perspective. A lot of beginner in programming try to a lot of beginners in programming struggle with the concept of recursion since this is their first time in programming and a recursion can be a little bit difficult for them. So I will try to explain the concept of recursion with the examples and I think so according to me the best way to learn anything in code is to learn it through examples, is to learn it through practical. So we are going to understand recursion with the help of basic code. Since you are learning recursion, I'm assuming that you know little bit of about programming till now, like how these integer variables are declared, how we take inputs, and how these functions work, etc. etc. Then only you should come and understand how recursion works. If you don't know the basics of programming, then you should go and watch the videos first and learn about programming. In this example, I will first say how this function is working, and then I will explain to you what is the basic difference between recursion and normal execution, which until now this code could be very similar to you, and it is very easy code. Let's us understand this code first. Here we are given a main function. Inside main function we have written a simple function. Now, how will this code work? So first of all, whenever we execute this file, it will look for the int main function. And inside it, it will start to compile the code one by one. So let's say it will first come to int a and b and declare these variables. And it will take input from user. Now, int sum is equals to add b. This line will get executed. And first of all, int sum is equals to this and then add. This function will get called and the execution will stop here. Then this function will get called and int a is equals to return a plus b. Until unless this function doesn't return anything, the execution here will stop. And since it is returning a plus b, the value will get stored here and it will get stored in sum. Similarly, the product will work and we will get our output from sum and product. Now, I have also added to a function divide here. Now, how will this function work? This function is not basic like these two functions. Divide function has an extra bit of logic in it. That is, if b is equal to 0, we need to return int min because division by 0 is not valid. This is just an example here. So if we ever met this condition, we will not execute this code here. Although this code is very simple, but we can have various code here which can be of any length, which can be of any complexity. But this is very simple code here for the means of simplicity. Now, if we hit if b is equal to 0, it will not execute it and return the value from here as well, and it will get stored in the variable which called it. In this case, since div2 is equals to 0, then div2 will store the value into n. And until unless b is 0, the div will also store it. If b is 0 and else it will not store and it will store the value of a divided by b. You have understand it very easily. This can be understandable very easily. Now, what if I need to function just like to calculate add, multiply, divide? I need a function to calculate factorial. If you are not familiar with the factorial, what the definition of factorial is, let's say 6 factorial, and the sign is of the factorial is equals to 6 into 5 into 4 into 3 into 1. This is how it works, and we can also say it as 6 factorial is equals to 6 into 5 factorial, right? We can say this as well. Now, I'm assuming that you know the basics of factorial and all, and you don't get confused in it. If you don't know the basics of factorial, I will go recommend you to watch what is factorial first. Now, in order to do so, I will create a factorial function just like I created a function for everything else. And it will take a just single argument into value. That is the value we want. Now, this value function should return this value. Whatever value we pass, it should return its factorial. Now, one way to do is by this. For int I is equals to 0, I is less than n, I plus plus. Now, it should be less than or equal to the value we pass. We will start with int result is equals to 1, and then into results star equal to 1, sorry, I, and this will return result. This is a function that will return a factorial. This is one way of solving the problem. Let's for now uh, comment this portion out. This was just for example. And int value c input value. Now let's say we will do c output value. Now let's take an example here and run this code first. This is taking a little while to come. Let's say we want to calculate the factorial of 4, which is 4, which is strange. It shouldn't give 4. I must have. Right, it is right. Oh, sorry. I need to do factorial of. Sorry, it was my mistake. Run the program again. And this is just a genuine mistake because I'm recording this video at 2:27 now. This kind of mistake may happen. Okay, 24, which is correct. Because 4 factorial is equals to 4 into 3 into 2 into 1. Now this is one way of doing this. What could be another way? I gave you a hint here. The hint is from this. That is, we can generalize this formula here. N factorial is equals to n into n minus 1 factorial. From this formula, what we can assume is, let's assume that our factorial function returns the value of factorial correctly. Now, if we want to calculate this value, now we will just return value into factorial of value minus 1. And this is by assumption that our factorial function will return the correct factorial of a value minus 1. But right now, it doesn't. How it can do it? It can do it if we add one more condition. If value equal to 1, return 1. Why did I say so? Because we all know that 1 factorial is equals to 1, right? So we don't need to calculate it, we just know the value. But we also know the value of 2 factorial is equals to 2. But I think so this doesn't make any more difference than this. We are just making it complex. So we'll just assume that we know the property 1 factorial is equals to 1, which is our base condition as well. Now, if we hit this base condition, we will return 1. What do you think so? That is this function correct now? I think so it is. So let's check it for now. Again, run this function and check. Is this returning the same output or not? I will input it for and 24 again. This means that this function, what I wrote here, this little function and this function performs the same output. It gives the same output for input. But how is this actually working? Let's now focus on this and I'm removing this part. How is this possible? Now see, I will explain you how this is working for 4 factorial example. Now, when I recall here int value and c input value, that is the value is equals to 4 now. Then I'm outputting c output factorial value and now value is equals to 4 here. Okay. Now this function gets called and it checks if value is equal to 1, which is not the case in here. So it will execute this code. This code will say return value into, it will work till now and then it will stop and pause. It will call factorial of value minus 1. Now see, instead this call is just same as in which we inside int main we called factorial and the execution stopped here and we moved into factorial. Now the execution will stop here and then we will move to factorial of value minus 1. Now currently the value was 4, which will now get converted to 3. Now we call factorial of 3 if value is equal to 1, which is not the case. The value is 3 now. Then we will come here again and value into factorial of value minus 1. Is this value 3, value minus 1? Now we are currently 3 and it will get converted to 2. Now the same will happen for 2 and it will get converted to 1. Now when 1 we will call here return value into factorial of value minus 1 from 2 minus 1 equal to 1. Now into value is equals to 1 now. Then this condition will be true. If value is equal to 1, return 1. This means that this function will not execute for value 1. Not executed for value 1. Very good. And thus will return the value 1. Now who called 1? From a call stack we can say 2 called 1. So if 2 called 1, then it will return 1 here. And in fact, it will now 2 will return 2, which was value 2 into factorial of value minus 1, which was 1. And factorial of 1 we return 1 here. So 2 into 1 is equals to 2. So now 2 will return 2, this value here. Now who called 2? We call 2 from 3. Return 3 into factorial of 2 minus 1. What was factorial of 3 minus 1? 2, which was 2. So 3 into 2, which will return 6, because we return 6 here. Now 4, who called 3? 4. So now return value into factorial of value minus 1 for 4. We give 4 into factorial of 4 minus 1, 3, which was returning value 6. Now 4 into 3 is equals to 4 into 6 is equals to 24. And this function right here will return 24. And now who called 4? We call 4 from here. It was called from here. That is how we will return 24. If you don't understand it, I think so I made it pretty clear. This was my first video, so I cannot draw it, and I don't actually know. I just made the video. So this is how it works. Now I will take one or two more examples. This factorial one was basic example of recursion. Now let us now come to the definition of recursion. Recursion definition is a function that calls itself to solve the problem. It is not different from any of the programming paradigm. Here, we called different functions as well, but this time we were not calling the same function. We were calling different functions and they will return in values. But in this part here, we are calling the same function. So we are calling the same function because we need to, this is a repetitive concept. Like for 6 factorial, as I said, 6 into 5 factorial. This is how recursion works. We solve the problem by calling the same function because we need the same computation, we need the same result again and again and again. We need the same logic to be very precise again and again and again until some condition is met and then we have to return it. Now, what will happen if I remove this return condition? And I want you to pause here and think what will actually happen if I return this value. If I commented out this portion here. Now, if you guess that this function will continuously calling it, then you are right. This function will keep on calling itself because there is no stop condition. The only reason it returned for value 1 and stopped the execution was because we explicitly said if value is equal to 1, then stop the computation and return value here. But even if now the value is 1, it will come here for 1 as well. And then from 1, it will go to 0. Now from 0, it will go to minus 1. From minus 1, it will go to minus 2 until our execution will get paused. And this is like an infinity loop, which will not stop execution. I can also show you right now how this will work. We should get an execution or any kind of warning, something, or it will keep on running and running and running. Let's say 4, and boom, keep on running. You might not have seen it, but let's say, see out here. This is also giving me a warning. Infinite recursion detected. Yes, this warning is correct. We have done it deliberately, intentionally. If you don't mention any condition here, then obviously this will give us infinite recursion. 4 and see, boom, here, see out here. It will keep on running until I paused it. This control C I did it to stop this execution. And as you can see, as we remove the base condition, the execution continuously moved. Now, how did I figure it out? Actually, when I was learning programming, I figured it out with the help of this debugging. Cout value here. I wrote cout value 1 here. And I wrote second cout value here. Now see the difference. You will also notice the difference here. See, observe how this function actually works now. I again give the input 4 and see 4, 3, 2, 24. How did this work? Actually, and as the answer equals to 4, and now return answer. It was not reaching this value because I was returning there first. And by doing so, this will also reach this value. I want you to visualize and see what is going on behind the scenes here. Oh, now see, when I first inputted 4 here as input, it gets called factorial 4, and now we come here. If value is equals to equal to 1, which is false, then we start executing. Cout value, which is 4 right now, then int answer is equals to value into factorial of value minus 1. Now, as I said, this execution for value 4 will stop here, and then we will call factorial of value minus 1. Now this is assume like this is a new function which we are calling with the value 3 as we called it with value 4 from here. This our code will not know that this is a different function. It will treat as the same function now. Since our value is 3 now, but it is still not equal to 1, it will come here and see out value, and which value is 3 here. Now we will again go for 2 and then we will see out value 2 here. Now see, we are not counting value for 1 here because if value is equal to 1, return 1. So this will not get executed. This code will not get executed. We will return 1. Now this return 1 will come to here first because 2 called it. So it will reach here value into factorial of 2 minus 1, which is 1. Now this will store in the 1 as previously the sum gets stored in the add product, it will get stored in answer. Now we will come back and see out value. Now currently the value is 2, so it will see out it and return answer. Now when we return this answer, it will get returned to the value who called it. The value who called it was 3. So now 3 will store the answer and then see out the value is 3. Now since 4 called 3, so this function will get executed. So this was all from my side for recursion. In order to understand recursion, you have to actually play with it, and this is the only way. We can also write it like this as well. So, okay, I can also say like this is correct. Yeah, so this is not correct, but this will not give the correct value of the factorial. But I'm just saying it for the learning perspective that we can also do this as well. So it's not compulsory that we can only call it once. No, we can call it any number of times because this is just an execution. This is just like we are calling a function. So if you want to really learn the recursion, do as I said, experiment with this function, and then you will be able to learn it. As I already spoon feeded a lot of content around this, I don't think so. I should spoon feed it more. You should play with recursion, especially this part. What will I do if I do this? And what if the condition is very poor? Like if I say if value is greater than 100, then return. In this space condition, it will not reach at any point. So if this not reach for any point, with value less than equal to 1000, then this will again go to infinity. So this base condition, here we call this base condition. This base condition is also very necessary. I forgot to mention the name. This condition is called base condition, and it is very necessary in every recursion call. Otherwise, it will become an infinite loop. जैसे कि for example, when we have condition in while loops, like while I is less than n, then execute the function blah 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 blah. If we don't mention this condition here, then the while loop will go to infinity. So this is the same condition with base condition here. If you don't mention a correct condition here, then the recursion function will also go to infinity. So that was all from my side to recursion, and sorry for the poor quality of video, sorry for my poor English. This is my first video and I'm just trying to upload it. So if anyone gets benefited from it, I don't really care because I got benefited and I made my first video.